Okay, so yesterday I was simply just providing an alternative way in which you can start your project in Prota. I don't know about the newer versions, but from 2018 up until maybe 2021, you can do that. You start from AutoCAD, you save your file as a DXF, and then you import it. I hope it's got similar functionality for 2025 or 2024 and 2025. So what I'm going to do is I'm going to open my folder containing all the material. Here we created a new folder yesterday. It's called the architect drawings, where I showed some of the architectural floor plans: the ground floor, first floor, roof, and one section. Unfortunately, for this set of drawings, we do not have elevations and a very detailed, maybe like a roof, because what we saw was that the roof plan was. Let me just open. What we saw was that the roof plan, it appeared to have three levels or three types of roofs, but then in the section view, it's only showing that there's a concrete roof. Okay, let's close this, and then as I do a quick review, a quick recap, let me also try to open Prota 2018. So if you've got any questions along the way, please feel free to ask.
Okay. Uh,
So this is the file that we had before it looked like this. It was simply just a plain floor plan. It didn't have any furniture layout, you know, only the doors, windows, and the walls also, the 200-inch walls. So we started by creating these axes in the in the x direction and the y direction. We put them on a separate layer. Here, when you go on layer properties, you create a layer. You call it structure grid lines. We give it a color. We give it a line type. And then after that, we went on to create. I think we showed dimensions also. We put the dimensions on one layer and how you can annotate your dimensions. And then after that, we created these columns. And then we created two kinds of columns. One that was like a portrait orientation, and then there was another one that was like a landscape orientation. Because why we did that was because in some sections, for example, in this section, it's impossible to have a portrait type of oriented column, essentially because there's a window here, and this is the way that the architect would much rather have it. So okay, good. So we decided to this one, we placed it in that orientation, the landscape. This one, it worked like that, and so on and so forth. And then we also added comments. For example, here, because this span is quite long, especially if I was to dimension from the center here to the center here, you can see that you have about 6.2 wide. And because of that, maybe here we'll require a deeper beam, but then definitely here we needed a column. We were not going to compromise, even though this architect had placed a very long window that was getting into the space. So we highlighted this area, we included a bubble, and then we added some comments. We said we might need to revise the window size to accommodate the 400 by 200. We did the same thing Here on the ground floor layout, you can see that uh, this staircase will need to be supported by the waste, the slab waste, and also this landing will need to be supported. This landing will need to be supported also somewhere. This is a concrete stair. So when it goes like that at an angle, it will anchor in this. It will anchor in this beam or column, and so on and so forth. And then these stairs will be used to access the first floor. So here we definitely needed a column. Maybe if it was steel, you would leave it. But for concrete, from there to there, you might need a support. So here, when you look at the oh, let me let me just pause it for a while.
Okay, okay.
All right. So going back to what we were talking about, I was showing that here when you pay close attention to the ground floor in this area, you see that the architect only has these walls to go like that. They do not end here, like the way that the, the here on the first floor is. So now, because we need this one to support the roof slab here, and so that we can have a continuous beam here like that, we decided to place one column. But in placing one column, we highlighted this area and we told the architect that I've added a column here to support the staircase. And then after that, I created a separate drawing. How I did it was I just selected this, the axis, the bubble, and what else? That line, the green line. Okay, so if you pay attention, I select once, I click once, this is right click, and then I highlight that. When I highlight the other green line also, even this one is selected, but I do not want to select the other one. So what I'll do is I'll hold shift and then I'll select this to deselect. When you pay attention, it actually has a minus sign, so it removes. And then since I've highlighted everything that I want, I'll right click and say select similar. When you look in the drawing, you see that everything similar to the bubble, essentially everything that's on this layer is selected, even this side you can see. And then because I want to move this into a new drawing, I also select this and this, and I'll say select similar. And when you see all the columns now have been selected, all of them in this drawing. So what I'll do is I'll right click and say clipboard, go to a clipboard menu here, and then in the commands in the clipboard, you've got copy with base point. So when you click on copy with base point, you can click the edge there, and then in your new drawing here, right click, you can paste like that. When you paste, it will ask you for an insertion point. You can insert it anywhere, and then from there you can see that, oh, okay, everything is intact. So we do not need both floor plans. We just need one floor plan. So here you can delete. And then from there, you save this drawing as a DXF here on Save As with the pencil. When you click on it, you can go to the folder that you would like to save this new drawing in. And before you save it, before you click on save, here you want to save the file as a DXF. So when you click on the DXF there, already I have one there, and then you can give it whatever name that you have for identification purposes. So since I'm just reviewing yesterday's work, I won't save this drawing. If you would like to see what happens, you can go to the previous drawing, previous video from yesterday on day 18. So here on my Prota, I can see that I've got this open project dialog box, and then it takes me to see, I've got a lot of files. It takes me to some of the drawings that I've done before. So what I would like to do, I would like to go to the other file there, because the file that we're working on is this one. the double story. So when I click on OK, Prota will load, and so this is where we ended. And then if you like, you can change your view here to go to 3D, and then you see that the columns have been inserted according to what we had done in AutoCAD. But then if I go to my plan view, I click and change to change to plan. You can see that my axes they've been labeled differently from the way that I wanted them to be labeled. So what I'll do is I'll put them side to side, these two windows, and then you can see that here it says Y1 up until Y7, I guess, because in the Y direction, and this is X1 up until X8 in the X direction. But I want the what I would like is for my grid lines to be similar to the architectural drawing, so that there's no confusion when the contractor decides to start building. I do not want him to look at the architectural drawing, see different grid numbers, and then when he looks at the structural drawing, he sees different grid numbers. So I'd like them to be the same. So because of that, I'll quickly change the numbers or the annotation of the grid lines in Porta. If you had been here from day one, from the first day without we started recording, you will notice that most of it is similar. So what I'll do is I'll select, right click, properties. I'll say this is my 01 or update like that. And then I'll do the same for here. It will say 02 update. And then I'll go on up until I exhaust all my Y direction. So this will be roughly update. I'll also be looking at the AutoCAD file there. This will be my 04 update. This will be my 05 update. Just to make sure I've got 6 and 7 remaining. Select, right click, 06 like that. And then the last one in my right direction will be 07. Okay, update. And then from there I can see that everything is working the way that I would like for it to work. I've got my 0, 1, 2, 3, 4, 5, 6, and 7. And then in my X direction, I just zoom out in the AutoCAD file. I'll see that I'm moving from A up to H. And then I remember we added some extras like B1 and E1. These were not in the architecture drawing to begin with. So let's be mindful. When we get to B, remember there's a B1. When we get to E, remember there's an E1. So that's exactly what I'll do. I'll start, right click, call it A, capital A, like that. And then I'll go to my B, like that. And then I'll go to my C, select. I'll go to my D. Oh, remember, already I've made a mistake. This should be B1.
No, not you are. Yes.
Yeah, I've already made a mistake here. So I'll just go back and say B1, update. And then this one will be C. And then this will be D, update. Let's see, A, B, C, A, B, B1, C, D. So now this is E. E, and remember we have an E1, properties, E1, update, close, and then this is F, update, It goes up to H. Okay. This is my G, and then finally my H. And then good practice always say you never know when Prota can have an error message, and then all the work that you've done will go unsaved. So Control S, you save your project after making very any changes or very big changes. Okay. So from here, I would like to set my levels. Hope that you'll be able to follow. Setting up levels in Prota is a little bit complicated. It's not as easy as Revit or even as easy as AutoCAD. So here, I'd like to see my work in 3D. I'll select this story, right click, 3D, and I can see that, okay, my grid lines have changed. And then, just at the back of your mind, as you work in Prota, try to make use of this 3D view in order to see the grid lines or where the grid lines are situated, because that's how you get to place your levels properly. So here, if I pay attention, I know that I'm in story 1 or level 1, and level 1 is 3 meters above the story 0, which is like the top of the foundation, or yeah, the top of the foundation, the stab column. So what that means is, even as you see right now, this column is too long. So if you click on this one, if you click on 0, 0, this is what it means. This is where 0 begins. So if you either ensure that your ground level is slightly lower so that you do not have any water ingress and you create a step, or so that you can actually have a room for one of those aprons. You know those aprons, for right?
Yes.
Uh, Usually the apron is maybe like 200 or 300 lower than the foundation slab, isn't it?
Yeah, of
And
course.
yeah, and especially for you, I know you've done a lot of construction work, so this is very easy. And to be a good designer, actually, it's good if you've done a lot of construction so that things make sense. So here, uh, what I'll do is I'll go into the building setup, just jump into it, and then actually before I can go into the building setup, I would like to look at the. Oh, someone wishes to join. Okay, neat. Good evening, Nisa. How are you?
I'm okay, thanks. How are you?
I'm doing alright. So we are on day 14. I don't know if you were able to review that video from day 13.
I'm doing that tonight. I was away yesterday, so I couldn't attend.
Okay.
I'm only getting free now.
Ah. Okay. So what's happening is that previously when we started the series, these sessions, we started with designing in Prota directly, and then we showed how to add grid lines in Prota. So that's one way of going about it. You start your project completely from scratch in Prota, and then you do your column placement. You insert your grid lines, then you insert your columns. So that's a lot of people take that approach. But then, if you've ever done any like consultancy work, you notice that before any job can come to you as a structural engineer, if it's a multi-story building, before a job can come to you, most of the times it goes through the architects, the designers, and then they'll dictate the orientation or the set out, how maybe the room placement. So for this session, starting from day 13, we used some architectural floor plans. And then for this one, it was I was very fortunate because for this particular residential house, the architect actually removed the furniture. Like I didn't have to go through the process of cleaning up the floor plans, what, so that I can only remain with relevant architectural elements like windows and doors so that they do not obstruct me when placing these columns. So I was fortunate. I think maybe the architect, whether they were using AutoCAD or Revit, and maybe they turned off certain layers and then they sent it to me. So that was very good. So what we did, I don't know if you saw those DWGs previously. All of this was not there. Everything that was there is just the walls and the white axes, and then we started by placing the grid lines in yesterday's video. In there, in the already existing, or you can choose depending on the span length. You can choose if you feel as if here you would like to have a grid line here, you can place it. But if you go into this drawing and you measure like that from there to there, you can see it's a 1.5. If you like, personally, that's a very short beam to me. Oh, Mkubis, I would like to join. Okay, good evening, Mkubesa. You found us in the middle. I was actually just doing a very quick recap. If you've been able to watch yesterday's video, then you'll catch up shortly. If not, I recommend that you go to day 13, then you watch day 14. But otherwise, I hope that you're doing good.
Waiting for you.
Yeah, I'm doing all right. So previously, our previous instructor was Mundia. He had shown us how to design that multi-story. I think it was seven-story building. And then I don't know if most of you were able to, but why he decided to do that seven stories, because before that I was doing the steel classroom with the steel connections, what. So he decided to do concrete. Although he took it up the notch and did seven story, I've decided to go back a little to backtrack and just do a double story using all concrete elements. So here I was just showing what we did previously. We received architectural drawings, floor plans, and one section. We didn't have any elevations. I would have loved to have elevations, but you work with what you have. So here we placed all this green, all the whatever green you can see, blue and red. We inserted it. Previously it was just white. So we created layers for dimensions, for axes, x axis, y axis. We labeled them to match the existing architecture axis, and then we started placing columns accordingly, just so we can see where the columns would sit well. And also, bear in mind, the architect has already designed these windows, these doors. I do not want to get into, you know. For example, this span is 3, 2 plus 1, 8 is about 5, isn't it? 0, 1. So that's a span of 5. I know that if I can use maybe a deeper beam, like maybe a 200 by 4 or 200 by 6, um, according to my experience, it would be able to withstand a 5 meter span, right? But also, that's the purpose of analysis. That's why we need to conduct this analysis to check. Since we're essentially still just in the design phase, if we see that it refuses or the software refuses, we can always adjust these beams and make them deeper and wider so that they can be proportional. The concrete proportion to the steel proportion can be according to the cross section of the member. So that's what we did there. We added some comments, we put these dimensions so that we can know how much spans we're dealing with. And I think in this x direction, the largest span that I noticed was this 4. Well, actually, this same 5. If you add the 1 8 plus 3 2 here, it means you have a beam that's spanning about 5 meters from one column to the other. And then there's that 4. But then if we go into the y direction, there's also this 5. But the longest one that I realized should have been, oh, here was this one. Initially, in video number 13, I was considering having it run, a beam run from there all the way there. Like if I anchor it here, and then from here, E1 to H, I wanted to see if I can cantilever it, but that was like 4 4. It can work, You can, if you're free and if you've got the time, you can try. And then as long as you make the beam deep, especially this one here, so that it's the primary, and then the other one can be like a secondary, and then you put edge beams around the first floor, it can work. But I decided not to do that. I would much rather be safe than sorry. So I added a column here and one here, meaning the only point where I'll have something like a cantilever will be in this uh, section here at number 5, 5H, because from there to there I'll have a beam, then this one will just be suspended, and then from there to there I'll have beams, and then here at the point where it will be suspended. And also, why I'm so confident in this happening is this will be like a balcony area, right? So you do not expect, except if you lived in China and you used to have parties at the balcony, then now that's an issue. But anyway, we'll run the analysis and then we'll see. So that's what we were doing. We were in Prota, I was with Paul, and then we changed these grid lines to match the architecture drawing, because I do not want, when the contractor is working, I do not want him to look at the architecture drawing and then the grid lines have a certain way that they've been arranged. And then when they look at the structural drawing, everything is different. I wanted to maintain a certain level of consistency so that when the contractor looks at the architectural drawings, they look at the structural, they'll know that okay, this is one structure. So before Niz and Wesa came in, we were talking about building sections, how to add levels in Prota, and then we were saying it's far much, a little more complicated than it is in Revit or even in AutoCAD, because from there you just add a level and then you have a different flow. So for example, if I go back to my um, section view here, so according to those DWGs that I shared in the WhatsApp group, for me I decided to place everything in one DWG. Like I used the ground floor. I copied the first floor from that one DWG, then I pasted it in here. I also got the section and I pasted it in here so that I can have everything in one. I can look at everything at once and not have to jump or open different files. So here, when you look, when you pay attention, the architect has um, estimated that they would like for top, the bottom of the footing from the ground floor to be 1250, and then they've got this 400. I do not know what that 400 is for. I don't know if they would like to have a 400 step. So that's like two 200s. I do not know. But anyway, this is basically just for reference or for guidance. So I'll measure from there to there just to make sure that everything is similar. Already I can see some inconsistency. Let me try to do it from, okay, let's see the thickness of this base. This is like 200. 200 for a combined footing for multi-story is not recommended. So from the slab, top of slab to top of footing, I've got that 1050. 1050 plus 200 should give me 1250. I don't know where that 447 was coming from, but let me just put my calculator and confirm. 1050 plus 200, 450. Okay, we're good. And then from the ground floor to, is this the landing? Or this is the lintel. They'll place either the ring beam or the lintel beam on 2 4, and therefore this is like 1 2. No, the ceiling level won't be applicable in the structure. So 1 2, the first floor is like 3 4. Okay, 1 2 3, and 4. Concrete roof level. So I'll go back. I've counted 4. I've disregarded this ceiling. Not necessary for me. I don't need to have a ceiling level in my structure, but I do need a concrete roof level. And I like that. Uh, where is this? Okay, put it here. I like that here he got it right. Because remember what I said in one of the videos, I said usually structural engineers would they'll their elements, the top is like 0 and then it goes down. So here I like that the architect got it right for me personally as a structural engineer. He shows that it's not counting from the bottom of the slab, it's counting from the top of the slab as 3.4. So there I can just go in, and I'm pretty sure maybe he used like a 200. He wants to use a 200 slab, okay, good. And then I'll go there, check, also 200 for the what? For the roof slab, concrete roof slab also. Okay, that's okay. So we've counted 4 levels from here to the lintel or the ring beam, and then from there to there, from there to another ring beam there, and then from there to the concrete roof. Okay, so I'll go into my Prota, and then I'll go to this building setout, and then I'll insert stories, and then I'll say 4, similar to the ones that I've counted. I'll say 4. If there's an excess, if there's a shortage, I can always add an extra. So when I click OK, it will give me this message that says this and the previous processes will not be undone after this step. Do you want to continue? Yes, I would like to continue. I'll say yes, and then there automatically it gives me these extra stories, and then I can be able to ascertain where they are. If I start while you're in your 3D, very good practice, click on your stories to know exactly where they're coming from. So from here, I'll click there, it shows me like, okay, this is my natural ground level or my 0, 0. It might not be natural, it might be, natural is like where the earth is. So this might be my ground level or my foundation slab level. And that's my 0, 0. And then it goes down, that's the stub. But if you start going up, I know that to the to the to the soffit there of the first floor slab, it's about 3. Although there it was 3, 4. And then from there, story 2 to the, oh, we're also missing out some ring beams. Anyway, I'll go to my building setup. Before that, Control S, I'll save, because anything might happen. Power might cut, water might malfunction, just give you an error message, and then you won't have your levels anymore when you come and reopen it. So good practice to save. So now what I'll do is I'll put this on the side like that, and then I'll call the section view like that. I'll have them back to back, and I'm doing this so that I can reference the levels there and the dimensions. I'll go to my building setouts. Now that I've inserted extra stories, I would like to edit them according to the architect section there. So let me just minimize it. I need to, oh, I forgot. Okay, cool. So remember the info section of Prota here in edit story gives you an indication of whether or not the floor that you're working on is populated. So here the only populated floor is number 1, story number 1, which has those columns. Everything else currently has not been populated. And so because of this, I'll change from, in fact, I'll start by changing the name, the description. So let's see. I'll call this as my ground level, and then the second one I'll call it as first ring beam or 1ST ring beam, and then the other one will be my second ring beam, isn't it? Or 2NG second ring beam, and then finally it will be my roof level like that. And then here I want this to maybe give me like a 115 total foundation, right? So that we can, sometimes you, it's not over designing, but you do not, for example, if you haven't done a soil investigation, you can still design, and then you can come and modify after you find the soil investigation. So here I'm working under the assumption that I do not know the soil investigation, but according to experience, I know that the deeper that I go, the better I'll find soil, right? In some instances, you might actually find an aquifer or a water table. But even if you find a lot of rock, you can always, like you can level it, and it's best if a structure is resting on rock, because it reads off things such as differential settlements, what. So here I just want my foundation to be deeper. I would like for a total of, I'll say maybe 1,200 at the top of my footing. And then a 300 thickness base will give me a total of 1.5. And that's usually standard, right? Unless if the structure will be situated in a place like maybe a marshland or a very swampy area. So that's why it's actually extremely very necessary for you to do some site visits. You go to the site, you check what kind of soil, you can be able to tell if you worked with soil for a while. Although ultimately, just to be certain, make sure that they give you a report, right? So here, my first story level, I would like to bump it up a little. I can bump it up by 200, or like the 400 that you want. I want to keep that 400 that's in the architecture drawing. I'll put it 200 just to have a step, and so that if the house is situated, for example, in a place like Chinika or Chinika heavy industrial area where there's a lot of water, and when it rains you have a lot of water, so that at least that 200 step can be give me room for example, so that water does not go into the house, right? And especially if you've done a proper drainage system, like if you have spoon drains or whatever drainage system, water collection, like that, it will be able to, the 200 will suffice. So here, before I can okay, I'll say, so actually this should be the one that's actually ring beam, or first ring beam, sorry. Number one should be first ring beam. I hope that I'm not too fast. If I'm being too fast, you can let me know. So I'll delete that level, just have first ring beam. And then here I'll have my first floor, first floor slab. And then after the first floor, I'll have the second ring beam. And finally, I'll have my roof. So from that 200 that I've given it here, I won't even consider it, but just bear in mind that we've bumped it up. We've bumped up the ground level of foundation slab by 200. And then to get to my ring beam here, it says 2.4. So I'll say 2,400 there. And you can see I've got a 2,400 plus that 200 gives me 2,006, right? And then from 2.6 minus the first floor is at 3.4. That's almost a meter, isn't it? Yeah. 3,400 minus 2,400. That's a meter. So here the height of this will be 1,000. But then of course when you add 2.6 plus 1,000, it will give you 3.6 here. 3.6 because we've got the 200 here, we've bumped it up. And therefore, if you pull out your calculator, 3.6 minus 200, you got 3.4. Everything is balanced. Okay, so from my 3.4 here to my second ring beam, it's saying it's about 5.8. So I'll just pull out my calculator to find the difference. 5,800 minus 3,400. It gives me another 2.4. So basically, we just duplicated 2400, there it will be at 6 as opposed to being 5.8. And then finally the roof will be at 6.8. So 6.8 minus 5.8 also a meter, right? So here I'll give it a 1000 height. And then entirely I was supposed to have 6.8 according to the architecture, but I have 7 plus the 200 here. Don't forget about the 200. Okay, and then now we'll say okay. If you like, we can say assume roof as normal story, but of course it won't be a normal story because except from the dead load, the only time that you need to access it is maybe when you need to maybe you know maybe waterproofing like that. So here I'll okay it and then I'll maximize it. Are you guys here? Okay. And then I'll maximize it and then I'll try to see. Here it gives me a plus 200 from there, bumped it up a little, and then from the ground to the ring beam there's that. And then from there to the first floor there's that 1 meter. And then from the first floor to the ring beam I've got that 2 4 again. And then ultimately I've got the roof at the top there. So why I'm doing this is generally just so that I can model everything. I want, since I know that Prota will give me a bar bending shape, roof, will create cut shapes, say the barcodes, what. I would much rather model the ring beam here also, just for my own good, because I do not want to go through the process of starting to get reinforcement bar bending schedules there, what. So I'll control S, and then I'll go to the ring beam level, and then I'll add a simple 200 by 200 ring beam. And then later on we're going to load it. I'll show you how you can. So I'll go to ring beam floor here, and then I'll change my view to plan view, and then it will go just around. It will not have anything in the inside. If there will be a door inside, they can always create just a simple lintel, right? But I'm only creating a ring beam for my exterior here so that my walls can be bound also. So here on concrete member, you can select concrete beam. Alternatively, you can go here and select beam, and then here on the section, it shows you that you're working with concrete. And then, as discussed, because in Zambia we've got, and also the blocks here, the ones that we're using, these are 6 8 inch, it's like 200 millimeters. So I do not want my beam, my ring beam, to exceed the thickness of the block. I want it to flush, right? So I'll say my width will be 200 and my depth will be 400. My depth will also be 200. Sorry, 200. Simple ring beam. We're not loading it with anything else except for the blocks that are going to come and sit on top. So I'll okay, and then I'll go like that from there to there, and then to there, to there, to there, and then I'll go there, 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 like that. Then this is the place where it's going to cantilever a bit, like that, like that. Go, and then I'll right click and update and close. I like to see how this looks in my 3D. Okay, we're good. So my openings will be at the bottom there. Oh, another thing, as I control save, control S, I'd like to look at my the architects section. Here you can see that 2 4 is from there to the bottom, not at the top. So this is good. Okay, I'll minimize and then I'll generate these columns. I'll generate them on the. I'll change to my plan view. Go to my ground. I'll filter, deselect, and then just select the columns, and then I'll highlight, and then I'll right click and go to oh okay, first floor. I've gone to the ring beam. This one is like a ground floor foundation. It won't read. So I'll go to my first floor there, do the same and filter, and then highlight everything, select the beams, right click, and then I'll generate. Where would I like to generate them? I would like to generate them on the first floor, the second, and the roof, like that. I'll okay, and I'll say yes. You see, everywhere it says complete, complete, complete. I'll close, and then I'll Control S to save. So before I can view it in 3D, it's going to look like this. So other in another way that you could actually model this is you can just make your columns go all the way up to the first floor, and then but because we're putting a beam, I do not want it to have like layers. So when you see, it shows that we've got one long and a short one, and then like that and a short one. This is acceptable since this is concrete. These are the construction joints that we were talking about. So for me personally, this is acceptable. If we were dealing with steel, then it would be a different case because I do not want steel to be cut like that. It's been supplied in 12 meters and 6 meters. And then if you cut it, it means you have to connect it by either welding or some connection, splice or whatever. But for concrete, I know that if I leave my concrete here, as long as I leave my starter bars, I can always just have a kicker and then come and cast concrete again and so on and so forth. And then it will be good. The loading will be transferred like that in any way. So while we are here in 3D, I would like to go, no, well, I'll go back to my plan view, sorry. I'll go back to my ring beam there, and then I'll generate this ring beam. I'll also generate it on the second ring beam. So I'll deselect this and select beam, and then I'll highlight all of them. I'll right click and say generate to the second ring beam, and then I'll OK. And then it tells me the process has been completed. I'll close, and then I'll take this back into the command, and then I'll change to 3D, and then I'll have something like this. You see? And then from there on, I would like to have now the proper beams, the load bearing beams. Just let me just control save this. So now I'll go to my first floor and I'll use 200 by 400 beams because these will be getting the loading from the use a 200 slab, a 200 thick slab on the first floor. So if we are going to be two-way, okay. So I'll go to my first floor, change to plan. You know that you can have there are about 4 types of slabs. I hope that you know this. There's like the one-way slab. There's a two-way, but either one of them they can either be flat or they can have like a tributary, the beam. And also the message that you sent in the group yesterday, um, Paul, it had something about the yield line method. So yield line method is used to usually to calculate slabs. if it's a two-way. I'm pretty sure maybe Prota has, does it have a help? Okay. So when you click on help, you go to there. Maybe you can search for like yield line methods. Oh, navigation. Okay. Welcome screen or search. Does it have a search? No search. Alternatively, if you like, you can go to the Prota website. Okay, quick start guide. Authorization about Prota. Mm, let's see. If you, this is a PDF. If you search and you say yield line and you click here, it gives you this information. So this PDF is extremely useful if you'd like to have further information. So here you see slab creation. That's where we found the yield line method here. It says click on the slab icon, blah blah blah. Then here to create a slab, position the cursor in the region bounded by beams. Region bounded by beams. So here when you look at this picture, the beams are this slab is being bounded in both directions, in all the four corners like this, 1 2 3 4, meaning the loading is being distributed in this direction, this direction, this direction, and this direction. And because it's being supported in all of these corners, it's got a two-way slab. But suppose I remove a beam here and here, now my loading is just being transferred here and in this direction, making it a one-way, right? Because, and also if you remember the can I pull out a pencil or something? Oh yeah, as a matter of fact. Okay. Okay. Let me do what Mundia did the other day. I'll pull out a pen, but I won't go as in depth as he did. I'll increase this and then I'll pull out my pen. So I'd like to have for it to be in red. These lines. So if you've got one, another, whatever, like that. Alternatively, I could have just used the red down like that. It's very big. Okay. So you've got a picture such as this one, and then if I put, okay, enter. Oh, okay. So here I can have green to represent a beam, another green, but I do not want it on that side. I'm not sure I did here. Another green, another green, another green, like that. This will make this slab two-way because, okay, enter. Because if I put a column here, another column here, and another column here, and another column here, it means if this is beam A, oh, font 18, okay, should be like, oh, wait, okay, so I don't know why this thing is working the way that it is. So if that's your beam A, and then you've got another beam B here, okay, now, oh, it's because it was very small. Anyway, you just quickly erase this, pull out my pencil. If this is my A, and it's just drawing. My paint has failed me. Anyway, if this is my A, this is my B, this is my C, and this is my D, meaning A, B, C, A, B, C. Beam at C is transferring in this direction and this direction. Beam at B, that direction and that direction. So what you draw in the middle like this and like that, what you draw in the middle like that and like that becomes the tributary or the yield line method. Meaning this portion will deliver to there, this portion will deliver to there, this portion will deliver to there, this portion will deliver to there. That's the concept of the yield line. You can pull out a PDF if you like, and then you'll be able to learn more like that. So you see, so select these two beams and so on and so forth. Okay, so going back to the video, um, the purpose was to draw those. Yeah, I was explaining about slabs. Are you guys following? Hello?
Yes, we are following. Yeah.
Okay. So I was talking about types of slabs. You can have waffle slabs. You can have those ribbed slabs. Waffle is where you use a lot of. Can I pull out my that book that I used to use? Ah, okay, I think it's the or the RC. If you would like me to share this book later on, you can tell me. Reinforced concrete. I think it's this one. This is the book that we used to use when I was at school. I think it's got chores here, continuous beams and one-way slabs. So I'll close this and I'll close this and I'll just optimize it on YouTube, enhance selection. So here it shows, oh, this is a simplified. It talks about bracing, but looking for slabs. Was that right at the beginning? Where they have that very nice structure with drawing that shows the orientation. Aha. So you see. So when you look at this here, the first one is like a supported slab, and it's called a supported slab because it's got beams in the edges. When you pay attention, there's one here, there's one there, and then the one at the top, they're calling it a joist slab. Other people call it a waffle slab because of the continuous things that it has. And then the one on the grade or on the foundation is called the slab on grade. And then you've got flat slabs. So a flat slab, the characteristic is that you won't have any beams. When you pay attention there at the bottom, you can't see any beam. And I've never really designed a flat slab before. I'm always scared of flat slabs. So usually usually just use supported or waffle, but I've never really just designed a waffle before. So most of the time it's just a supported slab. However, the characteristics of a flat slab is that you have very big columns. Also, King Salman was a flat slab. You have very big columns, but you also have these column pedestals. They call them drop panels here, as you can see. So what I'm going to do for this particular session, I'll design just a supported slab. And what that means is I'll go to my beam and then I'll change the orientation. I'll say I would like a 200 wide to meet the 200 column and 400 depth. And I'll say okay. And then I'll start running from there to there. If I would like to, for other extra things, if I would like it to be centric, or my I to be raised or my J to be raised, you can go to this properties thing. But for this session, it's really just a simple, nothing not too sophisticated, like that, like that, like that, like that, there, 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 and there, and there. And then from there on, I'd like from here to here to here. It's spanning from column to column like that. And then from there to there to there. Maybe can it off like that. And then it comes there to there. We'll see if it will be able to actually. Let me delete. Can I undo this so that I have continuous, so that the beams are not. Let's see. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I want the beams to have a certain level of consistency. 15, 16, 17, okay. Then this is 18, 19, 20, 21, 22, 23. Okay, Control S. So if you had noticed before, I went like this and then came here, then came here. But then that's very wrong. When you model it like that, you might have errors. What you'd much rather do is put one, go to your beam, make sure that the parameters remain the same, 200 wide, 400 deep. You'd much rather have one go there, and then you enter, and then from there it will come like that. This will rest on there. This is more acceptable. You see, you've got one main one, and then this one falls into that one. So this one will act as your main, this one will be your primary, this one will be your secondary. And then from there to there like that. And then I'll go from there to there to there, then to there, and then there. Okay, you enter. So now I was doing the Y's. Now let me do the X's. For example, this is the first floor right here. There to there to there to there, and then there. So now I've created like pockets for my slab. Here you can put your rebar there and there and there and there. So I'm creating those yield lines like that, there, there. Do I want it to anchor there? I do not. But let me just come out of this command, Control S. Let me try to see this span. I'll measure this span from 3 to 5. If it's below 5 meters, then I can just have one here. I've seen people make designs of 7-meter spans and slabs still hold. But nonetheless, I'll measure, right click, measure from 3 to 5, like that. It's actually 5, 4. We'll see what Prota will have to say. I'll go back to my beam command, and then I'll run from there to there. But while we're here, why can't I have a column here? Let me see. Between 3 to 5, I'll go to my architecture, and then 3 to 5. Oh, this is like an open. If I put a column there, it would be just on the ground floor, it will be visible. But here, 3 to 5, also visible. So we cannot have okay. How about here at E1? E, E1, E1 what? E1 5 appears as if we need a column to sit there like that. E1 5, let's see. E1 5, there's an opening. How about this is the ground floor? How about on the first floor? There's no E1. E1 5 here somewhere here. Here there is no opening. In fact, let me copy. So I'll copy this like that, and also copy this, and then I'll also copy this column, the hatch pattern, and then I'll copy it from here, and then I'll paste it here, and there I have my E1. It enters. Let's see if I delete it. Oh, it's good. Okay, it's resting in the wall, so it's good. But then at E15 here, what would happen if we added a column? Let me try to copy that from there, put it by the corner there, and then if I select it, copy it from copy it from here, copy it from there, paste it there. What happens there? It interferes with whatever opening this guy wants to create. Let's see. What happens if I delete? Oh, Control Z. Oh, are you still guys? Okay, I'm still connected. So what happens if I? Okay, let me make. Let me draw 400 from here. I'll say 400. Okay, so it's ending directly there. Oh, okay. Select that. Escape. Select that and select that. Then try to move it. Let's see. Put it there. Oh, oh no. I'm supposed to put it at E5, not F5. I've been doing it wrong this whole time. So E1 supposed to become like here. Okay, so the way that I moved it was incorrect. I'll find the intersection. I'll move it on the intersection in the middle there. My snap is on, and then I'll put it. This is E15, yes. And then I'll copy it now, including the hatch pattern. I'll copy it from a known point here. I remove auto, then I'll paste it here. Let's see where it is. Yeah, it's right in the middle. So this column cannot rest here. There's an opening, and therefore I'll delete it. I'll try to see if I would much rather just increase my beam sizes. Okay, so I'll go to Prota. Anyway, what is this span here? I'll measure from the center there to the placement here. It's about 6,200 this room. Okay, let's see if we can have it like this. This one is too big. I'd much rather have a beam here. What is this room, by the way? On the first floor. Oh, it's like one of those master bedrooms with a walk-in closet and a toilet. Mm. Okay, let's see what happens if I put a beam. From here, it will rest there. And then here also I can add a beam. Okay, Okay, system looks good. Control S. It saves. Let's look at it in a 3D. So the main beams are there. The ring beam. Okay. So meter below is it? Hopeful. So from there I can add. In fact, I'll generate these on the top also. So I go back to my first floor. Is it first floor plan view? But then if I select all the beams that we selected, so I'll just select that one control. I'll hold down control. Oh, okay, no, I can select them because the ring beam is only different. Yeah, all these are 400. Okay, so filter, beam, select, and then right click, generate, roof. Okay, like that. Process complete, cancel, and then when I go into my 3D view, I have this, right? Okay, and then Control S. Now I can have my slabs. This guy decided 200. Perhaps I can do maybe 160, 165. 200 is a little too much for a residential house. So, okay, it's a chat. Kindly share the textbook after your lesson. Okay, I'll share the textbook. So, where am I? Oh, I'm supposed to generate slabs. Generate slabs on the first floor. And then I'll go to my slab function. So this is the supported slab, or if it's not supported, if you use this command, then you could generate flat slabs. And then this one is the ribbed one. Later on when you're free, you can try to find the differences. But I'll click on the slab there, and then it brings, I'll pull it over on this side. It gives me these options like the label. If you like, you can have them be numerical, you can have them be alphabetic, and then the types. Number one is two-way supported, and then this is number five is like a one-way. So is number seven, and then I don't know what number eight is, but number 12 I know for a fact is a cantilever. So because also when you highlight them, I was expecting that they would give more information, but they do not. I'll use number one, which is supported on all sides, as you can see, and then I'll give it a thickness of maybe 160, right? 25 for a first floor slab is acceptable for me personally. If you like, you can bump it up to 30, meaning if you have 30 at the top, 30 at the bottom, because 60, the meat in the middle and thickness will be 100. But I'll maintain 25 so that it can be 25 there, 25 at the top, and then your concrete, your spacer blocks will be 25. Your insertion, do you want it to be the center to be, do you want to insert it at the center or in the corner and so forth? Will there be any angle? There's also that option here, beam region, axis, what. For me, I'll maintain beam region. I'll close that. And then on the loading, self weight of concrete is 3.84. If you do not believe me, let me just do a quick search here. Say, what is the self weight of concrete? There they're saying kgs. Yeah, you're saying 2,400. Hmm. Okay, I'll confirm later. But as far as I know, it's 3.84. And then the value, what is the purpose of this room for me or for this structure? Is it going to be a roof or room or terrace? These are rooms. The dead load there is 2.37. If you like, you can calculate the imposed load. Um, it's 1.4 Q plus, is it 1.6, 1.2 L. And then also alternatively, when you right click in there, you can have this generalized according to a British standard there. Is it 8110? And then you can choose the purpose. For me, it's a residential community. It's not, and it's using 1.5, or I can say bedrooms and dormitories. Okay. Hotels, anything larger than that, that need a lot of pressure or action on them, they start increasing there. Two, 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 two. For me, I'll say maybe bedrooms and dorms just to be safe. I do not want it to be limited there. So I'll choose that, and it gives me 1.5 big note. This relative level, if you like it to go up or down, you can put a figure. So for example, for the roof, because you need like water collection points, you need what are they called, those footballs or gutters or whatever. If it's a concrete roof, you need it to be collected somewhere. So because of that, you can make the roof to slope in certain directions. And then when you click this slab does not contribute to flow diagram, diaphragm, it means you will not have any. Also, this book explains the diaphragm. It's something like, let me see. How do you spell it? Dia PHNRAGM. Dia PH. Yeah, it looks like this. This PHG PHR AAGM PHR PHRA AGM. Okay. Here to the roof of these are slabs. Oh, just wait, and then the guys will catch us later. So I was on the concept of diaphragms here. Also, in Prota there, when you search the word diaphragm here, it says this is where you can show node labels, rigid diaphragm elements, and so on and so forth. So essentially, a slab diaphragm essentially works like a human diaphragm. There, is it along the belly, where it transfers to the legs. In the instance of concrete structure, essentially all the slab diaphragm will be translated either to the core walls or to the beams or to the column, sorry, not the beams. So if you tick this, then it will the analysis will not be as accurate. So you much rather just leave it like that, and then you start placing your slabs. Remember, we've loaded them. They have a dead load, they have a live load, and the self weight is there. And then when you start, what's going to happen is that as oh, someone wishes to join. Okay. I don't know where you ended as where you left the video at Lisa, but I think it was when we were discussing about the slab not contributing to a flow diaphragm. I tried to look up in Prota here according to the support text there. It doesn't exactly define what a diaphragm is. And also I tried to look up in the book also. Also it didn't. here. They are then tilted into their intended vertical position and fastened to a foundation to raise for a float diaphragm. Here it only makes mention of it, but I remember one time it was returning here. I remember one time it should have showed, but essentially, personally, the way that I might be wrong, so therefore you need to do further research. I might be wrong, but the way that I understand diaphragms in structures is the same way that I understand diaphragms in human beings. It's the diaphragm of the belly transmitting to the lower section of the body. Like you've got head, thorax, then abdomen. Then between the thorax and the abdomen is where you have the diaphragm. So essentially, in structure, it's similar. You've got a slab, it's transmitting to either the walls or the columns. Personally, that's the way that I understand it. I might be mistaken. So if anyone knows it in a different way, you can correct me. Or if you'd like to do some further research, you can always share your findings so that I can be well informed. But anyway, here we can start placing our slab. We've loaded it with a self weight. We've got a dead load of 2.375. We've got an imposed live load of 1.5 according to we selected it as being dormitory. Uh, it was dormitory or what? Communal what? Bedrooms or dormitories. And then here I've explained what the relative level is. This I know for a fact is if you need to slope your slabs. And then when you click this, then it means your analysis will hold back on certain information. Personally, I would recommend that you do not tick, you use the default. And then as you hover over this, you can see that it's defining you see, like it's defining the slab. It's defining it in a two-way. So it finds these boundaries, these four boundaries, and when you click on it, it actually gives that this is the symbol for two-way. This is a symbol for two-way system and not one-way. So I'll go and it calls it 2S1. One because here in general we had the level we had left it as one. Two because this is the second story. S because this means slab. So second story slab one, second story slab two, second story slab three, and so on and so on and so forth. Like that, 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 like that. There, there, there. Okay. And then um, I'll end. I'll update. Close. Close this also. And then I'll go to my 3D. I'll check. And then we have this kind of structure. I'll control S to save it. Let's see how much time have we done. Okay, it's like 123. I don't know whether I should finish modeling and then call it a day, so that in the next video you can just come and add the wall loads, the beam loads after running the analysis or prior to running the analysis. Also, this looks a little bit off to me, like this space. Maybe because from there to there, this is like 400. So just by looking, I don't think this is like a meter. And also, I cannot be able to tell because let's see, still because we haven't done the analysis. Oh, okay. So it's giving me a room of 600. What I actually need is 1000. So it uses the 400 for the depth and then the ring beam there. So what I'll need to do is either increase this so that it can give me 400 ceiling, but I'll run it by the architect. If they are comfortable having like a 600 headroom for the ceiling, then that's okay, right? So that's another trick that you can use if you'd like to see the dimensions. You click the column, this one will not show, but this one will. You click it, column two connections like that, it will show you. Okay, 2 2, then from 2.6 to there gives you that. If we had done an analysis, it would have shown you actually this, the reinforcement. So when I click on it, on column section design, I'm pretty sure it will give me an error message because we haven't done any analysis. Okay, so here another thing is that because remember some of the ground floor beams are colliding with the first floor beams, they are entering the rooms. In short, not all the columns on the ground floor will go to the first floor. Here they can only be used to support the first floor slab. Okay, so some of them are causing interference, they are protruding. I don't think the architect wants that. Good case in point is this one. This is number 3A. So I'll go to Prota on my not my window, on my roof there. I'll say, in fact, anyway, plan view. Here I'll have to forgo 3A, essentially because it's sitting in the window, and then my roof slab can be supported by my roof slab can be supported by my blocks if I can solid fill them, right? Like I've seen generally, even Zesco does concrete slabs, but we use solid filled blocks. So this one I'll delete it, and then which other one can I? This one at 6A, I'll delete it also. But is it getting in the way? Yeah, and this looks like a little duct row. If I yeah, oh, maintain it. Okay, now I'll delete it. Meaning in this axis on here I only have 3. Oh, but as I do that, let me change my view. 3D view, first 3D, that's A. A what? A1 to something. So my A is here. And sure enough, this one doesn't need to be there. Neither does this one. So these columns will essentially just support the, so meaning this has to be one beam. I'm seeing some errors here. Come and see, this one has to be one beam, but the span will be so long, but it will sit on the, will build here, it will rest on the solid filled blocks. So okay, that's good. I'll go to my plan view here, and then which other one? 3B has to go. But this, in fact, at 3 and 5, 3, yeah, 3B, 5B will go also, and then it will remain like that. What else? Do I need these stairs? I do not. I don't think I'll need accessibility to the roof here. I don't think there's going to be any opening. So these will remain on the first floor slab. I hope you guys understand what I'm doing. I'll delete this and this. What else needs to go? These are completely my own. So this is 5D and 7D also needs to go. 5D, 7D, 5D goes, 7D also goes. Okay. Outdoors floors. 5D goes, 7D goes. Okay, maybe I can have, yeah, I'll have E1, 5E1, 7E1. I'll maintain. There's actually no column on E1. Oh, 5E1, 7E1. Let's see. So meaning here I have to, oh, okay, here we said it will sit, but then here we said it wouldn't because of that. And therefore this one shouldn't be here. It will be a very big bond. Okay, 5E1, 5E1, 5E1. Oh, that one needs to go. What else do I have? 5G. 5G remains. I think we can maintain these, the boundary ones. Yeah, we're not causing interference. Okay, except for this one. So according to the section, you want everything here wants it to be like. This looks like a railing. Why is there a railing here? That's why we need elevations. So there, 5G looks like a column is just seated there. So this looks like a sliding door. They live there, they enter this side, they come, and then very awkward for a column to just be seated there. So this one also needs to go. 5G. So the 5G cannot go. What happens if it stays right in the middle? Okay. Anyway, we'll do that. Then we'll go to the 3D, and then it shows us all the other columns that need to go. I'll hold them down with control like that. Oh, so that one stays. This one goes. This one goes. Delete. And then we get something like this. Anyway, because we've run out of time, let me see if I can just have like a 120 slab on the roof, and another, in fact I'll say maybe 150 slab on the roof and 120 on the floor, and then we can come and continue tomorrow. So just save this and then also change some columns. Let's see, and view. Oh, the beams are still there. We'll see. I'll go to slab. For the roof, I would like to say, yeah, two-way, type 1. Thickness will be 150. Concrete cover will be 25. It's superstructure and substructure, so it's good. Everything else remains intact. And then self-weight remains 3.6. I'll choose flat roof because, well, it's no longer a room, so the loading will be less, the dead load. And then update, and then I'll choose that, that, and that, and that, that. so forth. Control S, and then I'll save. Okay, and then I'll go to my 3D. Of course, in for construction purposes, this is not correct, because it won't be flat like that, and water will be collected on the roof. So you need to have some collection points, so that also you can see that these are openings here because we deleted the columns that were there. So in the next video, we'll come and amend all of this. Okay, and then I can go to my 00 floor there, and I'll say plan view. Since this 00, the slab on grade can be reinforced with maybe mesh, either Conforce 193 or 257 will suffice. And also because there are no edge beams, you will see that the placement for this will follow the grid lines, which is, it's acceptable, it's okay. So I'll go there, slab, and I'll say okay, label, the type. I wonder what number 9 is. I've never used number 9 before. Anyway, in detailing in AutoCAD, we can show that it's conforce. So we'll maintain that, but the thickness we'll say is 120. For this one, I would like it for the cover to be something like 30, because it will be exposed to a lot of moisture from the ground. In fact, you can even say 30 is okay. And then the loading, also these will be just rooms. Post subgrade. What is this? Okay. And then you can see as I hover over it, it's not following the full rooms now. And then because of that, I'll have really small ones. Should be a better way. So there, FS1, like that. And when you pay attention, it's following the centers. Ideally, you want it to be there by the edge to flush with the columns. But that is something that can be corrected during drafting, maybe like in AutoCAD. Alternatively, you can give it like a slab edge, a thickness, so that the edges will be thicker. Some of these are really quite small, but we'll see. Should work. There, like that. And then I'll update and close. Then I'll change my view to 3D. Then I'll have something like that for the it went directly on the yeah, no wonder it was giving that minus 5,000. Okay, let me go to plan, select, select everything, slabs, select, oh, selected everything, including the axis. Okay, slab, highlight, okay, properties, thickness is 120 type 1, I'm out of it. Very. It's sitting on top of the. Okay, let me just close this. This definitely have to go. Let me delete them all. 3D. They needed to sit here. Okay, fine. So select one. No, I don't wish for it to be. Okay, sub build. Let's see, 200 open to. Yeah, let's see that it falls down. Oh, I've never encountered this problem before. A zero compressor. Could it be because of the. If I put it as zero, zero, sub, 3D. Yeah, all of them are here. Hmm. Okay, let me just cancel this. Go to my plan. Pull out select, delete all the stubs. Let me just pause this so that it doesn't. Okay, so here I figured out what the problem is. The problem was that it was reading that floor as the foundation. That's why when we were placing those slabs, it was writing F instead of S. So now I'll give this an offset of 200 here, like that, so that it will start at 200, and then my ring beam will be at 24, my floor slab will be at 6, and so on and so forth. So if I say OK, now what will happen is that when I change to 3D like that, if I select, oh, let me just give it a name as ground floor parameter. So this would be my ground floor, and then this is my first ring beam, first floor, second ring beam, then roof. Okay, so now as you can see, it's changed in this way. And if I select that at the bottom, if I select that, it should go 200 above. Then it's written that as okay. Building set out. Yeah, one so. Okay, should be there. Oh, is that 1000 different? Okay. Anyway, let me try to put the stuff here and see what will happen. 120, 30 concrete cover, and then my loading surface, it's a room. Okay, so now I cause it 2S1 and not the F that it was reading. If I go into my 3D view, still it's there. So is it requiring 1200? Using set out, edit, 1200. I can run my foundation. Okay, I go to the ground floor plan of the first floor. Select all these columns, generate them to the ground floor. Like that. Properties, generate to the ground floor. Okay, process completed. If I go to my 3D, okay, so now, yeah, so now we're good. And then building set out there, edit story, I give it a 200. Okay, now it's back to normal. Okay, and therefore now my foundation or my slab will be there. Then my stubs will be at 112 like that. So now I can go back in here, plan, and then I can select this, go to properties, and then I can put them like that. It's showing me a depth of 120, thickness of 120, like that. Okay, like that. Later on, we can create a section view or a call out detail that shows either 193 or 257 conforce. Okay, so this is good. Update, close, and then when I go into my 3D, this should make more sense now. Yeah. So from the ground there's that 200 bump, and then to my, oh yeah, this is my ground. This is my 0 0 there where my footing will fit. Okay. And then from there, the difference between that and that will be the ring beam will be 2 4 there, and then there's that one on the first, and then actually I can just do away with the ring beams. But anyway, this is where we're going to end the video for now. I don't know if you've got any questions. We can decide to whether model these ring beams in here, or we can just create a typical detail for the ring beam so that we can just have these other beams, and then we can also change this section. I don't know if you guys have any questions for now. So Control S. We're going to be in the next video. That's where we will load using blocks and also the other load cases. Hello? Nisa, do you have a question? Any questions, guys? Okay, if there are no questions, then we can end the video here because it's actually now it's at 1:50, almost 2 hours. That's very long. So end the video, stop recording.